In this video, we show some of the capabilities that make Agilent's Advanced Design System, ADS, the most comprehensive, easy-to-use, electronic design automation tool available for the design of high-frequency and high-speed products. It's difficult in 5 minutes to describe 30 years of development of ADS into the tool of choice that more than 20,000 designers use to make better communication products faster. But let's take a look at some of the major reasons. ADS has a rich set of tools that help designers fully characterize, optimize, and produce designs. The single integrated design environment uniquely provides circuit, EM, and system simulators, along with schematic capture, post-processing, layout, and verification capability. While ADS has the most comprehensive set of linear and nonlinear simulators, simulation is just one aspect of design. To help you create your product, ADS also offers a complete multi-technology design flow including full-featured RF and microwave layout, integrated planar and full 3D EM simulation for increased accuracy, a large set of physical and device models including X parameters and IBIS AMI models, statistical simulation methods for improving yield, high-speed channel simulation for designs requiring increased data rates, and a data display for powerful post-processing. Now we'll take a look at ADS in action. First, we'll start with the front end of the design flow, including simulation, post-processing, optimization, and statistical analysis. Then we'll look at the back end of the design flow, including layout and verification. It's easy to create a schematic and run a simulation in ADS. Watch as I set up and run an S-parameter simulation and display the results. Templates and design guides help you to easily set up simulations and displays for viewing data. Let's tune one of the parameters and see how the results are sensitive to the parameter value. Next, I'll set up a nonlinear simulation of an RF amplifier. Moving the marker on the data display shows how the performance varies as a function of input power. Using the powerful data display, you can learn much about your design's performance by post-processing and analyzing the data without rerunning the simulation. Once your initial design is done, you can use ADS's optimizers to further improve a design's nominal performance. Here is ADS's optimization cockpit. This popular capability is unique to ADS and makes the entire optimization process much simpler for the designer with a complete dashboard at their fingertips. In addition to nominal performance, it's important to ensure that your design has high yields. Here's a design that had poor yield. The spec calls for an output power greater than 26 dBm for an input power of 2 dBm. ADS's unique and easy-to-use statistical tools help to pinpoint the problem. This yield sensitivity histogram shows that by keeping a capacitor in the interstage matching network below 7.6 picofarads, the yield can be dramatically improved. Now let's turn our attention to layout. ADS offers a full-featured layout tool for you to generate an RF layout that is ready for production. With the largest number of fully endorsed Foundry design kits, ADS helps you lay out your design in your Foundry specific process. Accurate modeling of interconnects or transmission lines is one of the most important aspects of high-frequency and high-speed design. ADS's trace tool routes interconnects from one location to another, even moving between layers and automatically inserting vias. It's then very simple to convert the traces to transmission line models for simulation. Artwork can also be imported from other layout tools, and ADS's natively integrated electromagnetic simulators can be applied to the layout to create accurate models for simulation. This single interface for creating your layer stack-up is used for both the 3D planar EM simulator and the full 3D FEM simulator. The transmission line models and models from the EM simulators can easily be combined in the schematic for RF or signal integrity simulation. Here, for example, is a complete model of a PCI Express channel. It combines EM and transmission line models with IBIS AMI models. The eye diagram shows the performance at 5 gigabits per second. ADS helps you to ensure that your designs will work at ever-increasing data rates. Let's return now to our RF amplifier layout. To continue the design flow, a complete platform requires designers to have natively built-in DRC and LVS tools to ensure that their design is ready for production. Here, the fully embedded DRC tool shows that there are no design rule violations. Similarly, the companion LVS tool shows that there are no discrepancies between the layout and the schematic. So now you can send your design to the Foundry and be confident in its performance. You may want to put your amplifier in a package or integrate it with multiple chips within a module. Here's a 3D view of an amp in its package placed on a PC board in the ADS 3D viewer. ADS allows you to combine and simulate circuits designed in multiple technologies at both the circuit and the full 3D EM level. This is a unique capability of ADS. You may also want to generate a model of your circuit that can be used at a higher level system simulation. Agilent's X-parameter innovation gives you the ability to generate a fully nonlinear X-parameter model in ADS that you can provide to colleagues or customers for simulation while simultaneously protecting your IP. These are the same X-parameters that you can measure with Agilent's nonlinear vector network analyzer. In the last 5 minutes, you've seen some of what makes ADS so popular with high-frequency and high-speed designers. You've seen how ADS offers a complete multi-technology design flow, including layout and verification, integrated EM, and advanced models such as X-parameters, and there's still more. ADS is the most comprehensive, easy-to-use electronic design automation tool available for the design of high-frequency and high-speed products. For more information, please visit us at this website.